So we went through our in-class problem that allowed us to practice balancing a redox reaction, and now sample problem 21.1 allows us to practice that again. So I'm going to go through this one a little bit more quickly, assuming that we've already gone through that in-class problem and we understand the 4 steps to balancing a redox reaction. First is to generate our 2 half reactions, then to balance atoms and charges in those half reactions, scale up the half reactions so that the electrons gained equal the electrons lost, and then combine them together. And then again, because this one tells us to balance in basic solution, we're going to need to go through and replace any H plus atoms that we have that we use for balancing with OH minus. And again, generating water and get those to cancel out. If that was a little bit too much to just kind of throw at you for this first sample problem, you might want to go back and review the in-class problem on balancing a redox reaction. Okay, so the first thing we need to do is split these up into our 2 half reactions, again, finding things that have common atoms. So we're going to have our permanganate and our manganese dioxide. And right now, again, we can omit writing phases as we are balancing these here. And then we're going to have our oxalate going to our carbonate. So taking the left half reaction here, we need to balance our oxygens with water and then balance our hydrogens with protons. So that's what we'll have here. Summing up the net charges that we'll have here, 1 minus 1 plus 4 plus 1s is going to give us a net of plus 3. Net over here is 0, so to have these two equal, we need to add 3 electrons. So the net for this, 4H plus MnO4 plus 3 electrons gives us MnO2 plus 2 waters. Since we've gained electrons here, this is our reduction. On the right here, again, balancing waters means we've got to add 2 waters on the left, balancing protons with protons for the water, net on the left, no charge, 1 thing at minus 2, balancing on the right, 4 positives, oops, there should be a 2 in front of there, 4 positives with 4 negatives, net is 0. So to get these to balance, we need 2 electrons there. So summing these up, we're going to have 2 waters plus our oxalate gives us 2 carbonates plus 4 protons plus 2 electrons. Again, electrons being lost. That's our oxidation reaction. Now, unlike we had with our previous problem, where we could use just a single coefficient to scale up one reaction, we can't do that here. We actually have to scale up both of these. We're going to multiply this reaction by 2, and we're going to multiply this reaction by 3. And that will give us 6 electrons being gained in our reduction, 6 electrons being lost in our oxidation. So I'm going to take a little bit of a shortcut here and not rewrite my scaled up reduction and my scaled up oxidation, but I need to make sure that I push this 2 through every single term here. Remember that our electrons are going to end up canceling, so we won't have those. But again, I need to make sure to push that coefficient through each. So I'm going to have 8 H pluses plus 2 MnO4s plus, 6 waters here, plus 3 oxalates, gives us 2 manganese dioxides, 4 waters, 6 carbonates, and 4 H pluses. Oops, 12, sorry. 12 H pluses. I'm already writing my canceling. What we can see now is there are some species that appear on both sides of our reaction. Water happens to appear on both sides. So 4 waters can go away here and leave 2 here. Again, protons appear on both sides. 8 protons can go away and leave 4 there. So in acidic solution, if we go ahead here and then add back in our phases, 2 permanganates plus 2 waters plus 3 oxalates gives us 2 MnO2 solid plus 6 carbonate plus 4 H plus. So again, that's acidic solution. This problem asked us to solve it in basic solution. So what we're going to have to do now is we have to get rid of the H plus, which means we need to add 4 OH minus to each side. So adding 4 OH minus to 4 H plus gives us 4 H2O. We already had some other H2O on the left side here, so those are going to go away and leave 2 waters there. That's the only thing we need to worry about canceling out. So now if we summarize this in basic solution, 2 permanganate plus 4 hydroxide plus 3 oxalate gives 2 manganese dioxide plus 6 carbonate plus 2 waters. A fully balanced redox reaction in basic solution. Again, if this one was a little bit too quick for you, please go back and look at the in-class problem right before this one to kind of go through a little bit more slowly how to balance a redox reaction.